I am a missile system instructor right now. I teach it to the new fleet of the Navy. And prior to that, I was a NATO Sea Sparrow surface missile system operator out in the fleet. And, we went through very, very rigorous training, electronic training, troubleshooting, operation, everything. We have detailed schematics on how our system actually works, all the way down to how the circuitry of all these circuit cards that run our system are laid out. And, like you said, I can't get into anything super specific, but I will tell you that with my missile system, we have the ability to track something, 50 nautical miles away with our radar that we use for this missile system. And as far as this specific missile system goes, the way it essentially works is, let's say we're tracking some enemy aircraft, and it's, 45 nautical miles away, which is over, 50 miles away. First of all, you have to understand that our radar, the beam width on it is only 2 degrees from its point of origin, which is the radar itself. And it's a fire control radar, which means that it's not like a normal search radar that just spins all day arbitrarily. It's a tracking radar. So it stays fixed to the target that it's tracking. It's not sweeping it, every few seconds. It's looking right at it all the time. That's how we maintain our track. So you have to ask yourself, okay, well, it's a 2-degree pencil beam. It's looking at something 45 nautical miles away. That's not possible if the target was flying at 100, 200 foot off the ground. That should still be, well below the horizon of a curved model. And I have no problem tracking a target like that. Absolutely none. I can stay locked up on it all the way till it flies over my ship.
Okay, so now wait. Now, at what altitude are you above the surface of the ocean from your tracking station?
The surface of the ocean, the radar itself is roughly, it's like 120, 130 feet above waterline.
Okay, so you're 100 feet above the waterline, and you're tracking something else that's about 100 feet above the waterline. What aircraft or another ship that's on the waterline, or anything.
Yeah, we'll say aircraft for now.
Okay. So you're talking about aircraft. Well, wouldn't they be flying higher, or that would be? Why would they be flying that low?
Well, they would be flying that low because most people think when they hear about a plane, they think commercial, plane, 30,000 feet. However, when I'm talking from a perspective of my weapon system, it's meant to shoot down bad guys. And what do bad guys do? They take a low flying profile and they sea skim off the surface of the water. Reason for that is because they like to defeat the blind zones in a radar's wave propagation. The closer they can fly to the deck or the water line, the more invisible they are on a radar. So that's why I say 100, 200 foot.
Okay, so then if it's flying about 100 feet off the deck, then it's flying pretty close to level to where the height of your radar system. Then.
Yes.
So we're talking, give or take, fairly even ground on both ends at a distance of 45 nautical miles. I just punched up a nautical to statute mile converter. That's about 51.7 statute miles away, which on a ball that's just ridiculous. 50 miles on a ball would be 1,667 feet below the curvature. But yet, now, is this a line of sight deal, or is this this pencil radar you're talking about?
It is a line of sight radar. The argument always comes up. Well, it's radar refraction off the ionosphere, in the atmosphere. And that's always the argument with like major wideband search radars. Well, guess what? Mine's not a search radar. It's a fire control radar, which means that it has to be so accurate it's used to determine our intercept point for the target that we're shooting at. And it has to maintain a direct line of sight lock on the target to actually strike it with radio frequency and then receive that reflected radio frequency back into our receiver and maintain the track on the target.
Wow. That's just, at the very least, it is proving that if we are on a ball, it's way bigger than what we've been told. So no matter what, we've been lied to.
Yep.
So, okay, so this thing, this pencil beam, this is tracking something, and you're actually watching something 50 statute miles away at roughly the same altitude as you are. So, that alleviates the question of, well, maybe you're higher, so you've got a greater field of view or whatever. You're tracking something that's about the same level.
Correct.
Wow.
Yep. And that's just one aspect of it all.
Okay.
I can go into more detail than that.
Bring it on. Whatever else you're able to share, bring it on.
All right. So, for instance, we got the tracking of the target out of the way. Now, NATO Sea Sparrow's missile system works upon a semi-active doctrine. And for any of those technical buffs out there, you probably know what I'm talking about. But the way our missile goes after a target, let's say we already established tracking it, let's say it's within our missile's engageability envelope now, which is only about 10 nautical miles, which isn't very far, I understand that. But let me hit people with this. When we shoot our missile is based upon what the reflected energy from the transmitter is. So that's how it goes after the target once it's in flight. It's a semi-active missile, meaning that it has to have a constant lacing, so to speak, of the target by that transmitter, by that that RF coming out. It has to have an external designation source. So at any point, if that designation source isn't tracking the target, then the missile is essentially blind, so to speak. So what that draws into it all is whenever that missile is in flight, there's absolutely no signals that are being sent to it that deal with the Coriolis effect. There's no signals that deal with curvature and dealing with, curvature trigonometry. It's based upon a planar model. Even our fire control computer, whenever NATO was established and came together as a big think tank to make this weapon system, it had 13 countries involved with it. And, several of these countries created different parts of the system, and it all got the name of weapons defense contractor by the name of Raytheon slapped on the title of it. And, when you look at this thing, the radar that calculates all this, the intercept points and, how fast the target's going, what our missile's doing, this computer, it comes from a Norwegian tank. That's the computer. So it's based upon old technology of firing artillery shots, which only deal with an X and a Y coordinate scheme. Okay. Which, for anyone that doesn't know, that's a flat model. That's not a curved model.
Yeah, okay, so this system was taken from a ground-based deal. Now, that Coriolis thing, because one of the early pushbacks that I got when I first started looking into this was from infantry guys. And, guys are shooters, and they always were about the Coriolis effect, saying, long-range shooters always have to adjust for the Coriolis effect. But it seems to only apply to bullets, because what I could tell, it doesn't apply to missiles, it doesn't apply to cannonballs, it doesn't apply to, pretty much anything except bullets. Is that correct? What would your answer to that be?
Well, my answer to this would be I absolutely have no faith in the Coriolis effect at all, because first of all, you're talking to someone that believes in the flat earth. Coriolis effect doesn't exist. Second off, the people that sit there and acclaim, oh yeah, we have to take this super long sniper shot, the Coriolis effect, into account for this super long shot. I think that has to deal with self-aggrandizement and brainwashing, honestly, because it's not something that's taught from a practical sense whenever these people are trained on any of this. Long-range snipers are taught, distance and windage. That's all they're taught. And whenever you think about it, the scientific community that brings up the Coriolis effect, like the other day, what's his name? Neil deGrasse Tyson. He tweeted that some football game, they missed the game-winning field goal because of the Coriolis effect and how it shifted the ball, 3/4 of an inch to the right and made it miss, outside of the pole. And I say this, if that's true, and that was only a 40-yard field goal, and it moved it 3/4 of an inch, let's go ahead and re-examine how long these sniper shots are. Some of them are up to a mile and a half away. You have to conceptualize this. If the Coriolis effect has that much of an impact at 40 yards, let's go ahead and ramp it up to, 1,000 yards. You're talking about huge deviations from where you're originally aiming at.
but some of these guys, they say that if you're in the northern hemisphere, you got to correct it. I don't know if it's left or right, whatever. Let's just say left for the sake of argument, because I have no clue what I'm talking about. So let's say in the northern hemisphere, they say, well, you have to adjust it X, Y, Z based on the Coriolis effect to the left. But if you're shooting in the southern hemisphere, you adjust X, Y, Z to the right because of the Coriolis effect. They have these arguments. I've seen the videos where they got these, reality TV show guys talking about it and, talking about, the long-range weapons and how they work. But it seems like, because I've heard stuff from other people that other than long-range shooters of bullets, people who shoot other things, and it doesn't seem to play into it. Do you ever have to adjust for Coriolis effect if you're shooting a missile or
I'll put it to
cannon?
I'll put it to you this way: the missile, I don't even think it's arguable that I can hit a target much further away than a sniper can. And I will tell you this, there is absolutely no circuitry designed into the engineering of our missile system that accounts for anything closely resembling a Coriolis effect. Absolutely not. Okay. Not at all.
I got this guy on my Facebook page named Randy. He said, I spent almost 4 years on an aircraft carrier, the USS Independence CV-62. I have phoned home from halfway across the world and studied the skies and ocean with telescopes and the naked eye for hours and days. The Earth is a sphere. This is one thing I can say I know is a fact. Caps. So what would you say to Randy of the USS Independence?
I would say that he's been drinking the Kool-Aid and he likes the taste of it, honestly. I don't discredit anything to his service. Everyone knows I'm in the service as well. But the arguments that he made, how can you make such an outrageous claim? I know for a fact. Well, tell me some empirical evidence. Give me an argument of how you know for a fact. You study the stars. You study, all this stuff, all this time you were in. I don't know his background. Did he watch something? Was he responding to something that you said? Or what?
He's responding to this the Facebook post I made for this radio show, so he's probably listening to us right now. And that's what I want. I want various professionals out there who are in this field or fields like that to weigh in on the discussion, because this is stuff I don't know anything about. I'm curious and I want to know. But I love being on the ocean. Anytime I've ever been on a cruise, I come alive. Like I should have been a pirate or something, because I just love the open sea, man. But anytime I've ever been on the ocean, it's flat every direction you look.
Yeah, and like I said, no offense to him at all, but you really need to re-examine things before people make outrageous claims, that they fire from the hip all the time. Like, who are you trying to convince? I'm glad you said it in all caps, but bring something tangible. Bring something to the plate that I can examine, that I can retest. I can show you a room full of flat earthers that can sit here all day and disprove arguments that are made from a globular standpoint. But I can bring also a room full of globalists that can come into a room, and when you ask them to bring something tangible or debunk something that a flat earther brings up, and all they have is nothing tangible, nothing testable, unless you want to talk about how how they were raised as a person, because all they can spew out of their mouth is rhetoric and name calling and you're an idiot and all this other stuff. Like, I don't buy it anymore. You can sit there and trash talk all day long, but until you bring something to the plate other than preconceived notions and tantrums like a 10-year-old, I have no time for that.
Well, everybody will show you NASA-based stuff, as their proof. Okay, let's get back to your field of expertise.
Okay.
What else can you tell me from your experiences on the high seas and working with the equipment that you've worked with?
Yeah, no problem. Another thing that I bring up, my weapon system, when we're aiming at a target, obviously people know that our ship pitches and it rolls because of the seas. So you have to take into account the pitch and the roll of the ship. That information has to be fed into our weapon system so we can stay on the target, because if we didn't have a system that could feed into it like that, you got to think about it. If our ship takes a huge roll, our radar is no longer going to be pointed at the target because we moved in relevance to where the target was at. So what we use for that, to compensate for that, is this system. It's called Wizen 7, and it's a gyroscope. It's a laser gyroscope that feeds and updates our weapon system so they can maintain on the target. And for anything that knows anything about gyroscopes, for anyone that knows anything about it, they know that once a gyroscope is spooled up to its operating RPM, it has this really, really innate ability to counteract the effects of gravity and any type of precession on it, meaning that once it's spun up, it maintains its relative plane. It does not care about any outside force at that point. And you think about it like this. Once it's spun up, our ship literally pitches and rolls around it. It maintains its flat plane. So that's how we stay on the target. So if this system fails, you have to consider this. If it doesn't work the way I know it works, then there's no way we could stay on a target when we're in heavy seas and our ship's rolling all over the place. It's not possible. So, since I established that, I always say this. Well, gyroscopes are also used in other pieces of equipment like aircraft, and they are used to give you the attitude of where the aircraft is pointed. Now, I always say, I try to have people conceptualize this. Imagine an aircraft that's on the North Pole, okay, and it's looking out flat. If you can imagine a globe, all of a sudden, that plane would make a straight horizontal line across the top of the Earth. Now, when that plane takes off, because that gyroscope does not change its perspective, it maintains that flat Earth, and it is what feeds the attitude indicator to let your aircraft know that you are at level flight. If you travel to the equator and it's still maintaining its flat, attitude, eventually your instruments would look like you're taking a total nosedive all the time on a globe model.
Okay.
It would look like you're pointing at the ground all the time.
Yeah. I listened to the interview Mark Sargent did with the airline pilot. That I guess, I don't know if he heard it from you first about the gyroscope, and it got him thinking.
He did.
Have you talked to him?
I have, actually. I was the one that brought it up first, and that aircraft pilot, he actually, confirmed it from his background of how long he's been flying planes. And I'm actually very grateful that I compelled him to come out and talk about it. But you have a situation on your hands with that, because if you go by your instruments, and pilots and military personnel are always taught to have 100% faith in their instruments and believe them because it'll never steer you wrong, you have to assume this. If that orientation from the North Pole stays flat and you follow your flat attitude indicator, think about it like this. You're flying the North Pole and you're going to stay flat in your orientation, which means from the perspective of the globe model, you're going to be steadily climbing in altitude till you get to escape velocity of being outside the atmosphere, if the globe model is true. It's not like this gyroscope keeps adjusting all the time as you're going around the globe. It's not possible. If it was possible, then it's not an accurate system. It's not a dependable system to maintain a flat plane, to feed weapon systems, to maintain, their track on a target. When a ship's rolling, you can't have it both ways.
No, I'm not exactly familiar with that, like how the equipment. I know what the equipment does. I mean, I've used them myself when I was flying, but like the mechanics of it, how does it work? I mean, when it spins up, is there like, I don't know, a weight or something on the bottom of it that keeps that as bottom? I mean, because it's spinning up, right? Like it's spinning horizontally.
It is. It's spinning horizontally. The actual gyroscope itself, imagine this. You have a solid disc, piece of metal. It's a big hunk of metal. And it has gimbals around it that give you your pitch and yaw and, roll. So your X, Y, and Z for a plane. Now, when it spins up, it stays at its own orientation of however it was spent up. So after that point of it being spun up, it will not change orientation because it is what gives you your reliable readings of how your aircraft is pitched and yawed and rolled around it. Think about it from this perspective. If you had to pull back on the stick all of a sudden in your aircraft to go over a mountain that you were coming up on, it gives you a reliable pitch indicator. Imagine that mountain kind of like the curve of the Earth. If it had to do with being pulled down necessarily towards the center of the Earth, then it should give you a false reading after you get over the mountain. But sure enough, it never does. It goes back to level flight after you climb over the mountain.
But when it's spinning up horizontally, is there like a vertical weight on the bottom that says, okay, this is plumb?
No.
Okay, so it doesn't have any kind of a weight or something that would be gravity related, saying this is a plumb line.
No, because that's the whole point of a gyroscope. It's to counteract the effects of gravity, so you can determine where you are pointed at in free space, just in the open air.
I'd love to get an avionics expert out, if there's somebody out there who understands this, because I know what it does. I mean, I've used the equipment, but I don't know how it's built, like how it works on the inside. Have you looked on the inside, like how the thing
actually works? Yeah, I have, and it has no weight to it. And furthermore, gyroscopes have been updated in advance since then. You really want to argue it. The new laser gyroscopes that we use, they don't have any established weight. They use light as a point of reference. They spin up a disc that shoots out lasers that is the point of reference for it. And they have a digital encoder that deciphers where the laser strikes inside of the gimbal system for it. So you can't even argue gravity anymore.
All right. Talk about that when we come back.
All right.
Squared with Brooks Agnew. Sundays on Truth Frequency Radio.
And welcome back to the Revolutionary Radio Project. I'm your host, Rob Skibba. For this final segment of the broadcast, I'm talking with my guest, Sean McCrary. And right before the break, we were discussing gyros and how they function. I just went on Google and punched in gyroscope and sent you a link in the Skype chat there, if you got it. This is what we're talking about, right? This weird-looking spinning top type thing?
Yep, that's a gyroscope.
Now, that vertical post thing, I guess, is what I was talking about, wondering if that was like a plumb bob kind of weighted deal that says, okay, this is always pointing towards ground.
Yeah, I understand that argument, and the way I try to explain it, as far as the center post, that's just the means of the disc rotating around it. That's what gives it its axis, so to speak. And my argument, my counter argument to people saying, well, it's just aligning itself to the center of the Earth, and it just adjusts around it all the time. Well, that would make sense, but you have to understand, if that were possible, then gyroscopes would not be as reliable as what they say they are. They would not be used in multi-million-dollar weapon systems to make sure that we can hit a target over, 40 miles away. It's not possible. You can't have something that loses its rigidity in space whenever you want it to, just to explain it away, because it has rigidity in space to maintain a flat plane, a coordinate plane, to establish benchmarks like being able to put a round on a target, if you're talking about it from a military aspect. So, yeah, you can't have it both ways. That's what I always say.
Now, when I first punched that up, and the link I sent you, those are all mechanical gyroscopes, but there's some kind of digital gyroscope in our iPhones now, and our iPads. That it knows, what the attitude of the device is. So, is what's going on with that? What type of devices, electronic gyroscope going on in the iPads and iPhones and stuff?
That is not an electronic gyroscope. It's actually called an accelerometer, which is a little bit different. It has the ability to maintain a level perspective. Basically, imagine a long cylinder, okay? And in the cylinder, you have a metal ball. Wherever the metal ball rolls back and forth, on the bottom of the cylinder, there's little outputs that say, "Oh, the ball's over this part."
Gotcha.
Depending upon where the phone is pitched, and all it has is a back and forth and a left and right cylinder that measures, this ball going back and forth, and that's how those phones work like that.
Okay, gotcha. Yeah, I was fascinated by that. So that whole discussion. I mean, so you brought it up. Then did Mark get you in contact with the other guy? How did you guys and you're an instructor, so you're talking about you're a missile systems instructor, and this guy is a flight instructor. How did you guys end up connecting?
Honestly, he figured out about me through Mark's interview, and I guess he'd been watching for a little while before that, before I came along. But yeah, we just reaffirmed a bunch of each other's different viewpoints on this subject. And, I'm going to be honest with you, I have absolutely no experience in flying other than the fact of, I've messed around with simulators, very sophisticated simulators, but still simulators nonetheless. However, the equipment that's used in, naval warships is the exact same principle theory equipment that's used in aircraft to give the same result. So I feel like I can still speak on it from the perspective of being in the military and dealing with this equipment that deals with my equipment that I work on every day. And, he saw that, and he saw the validity to me bringing it up, and yeah, it was just great. He absolutely confirmed everything I said and everything I thought about the topic, and I've done more and more research on it myself, and yeah, I always try to keep in close-knit ties with everybody that has something to bring to the table on that subject. I try to collaborate as much as I can.
You know, I've got a ball that I bought at, I don't know, Walmart or someplace. That when I don't know if you saw the video I did where I debunked myself. Rob Skibba debunks Rob Skibba, where I did this experiment in the hallway of my office complex. I was trying to, you know, the NASA video they put out of the moon going across in front of the Earth, and I was saying, well, the scale's all wrong. If you're on the moon, the side of the moon facing the Earth, and if you wanted to take a picture of the Earth, then the Earth would fill up the entire sky, at least the way it looked in that perspective. But it's really an optical illusion, and I ended up debunking my own argument in the hallway when I did that. But I've got that ball sitting right next to me here on a table, and I was thinking about your analogy of the airplane taking off from, let's say, the North Pole. So I'm looking at this ball, seeing an airplane just flying out straight to the right, you know, from my perspective. And yeah, I mean, if the gyroscope is spun up to say this is level, then if it was going to maintain level, according to what I'm hearing you say, that there's no counterweight saying, hey, this is the Earth below me, constantly readjusting for level, then if you were to fly level off the ball, you would just keep flying off, like you said, until you flew off into space. So you'd have to then always be correcting nose down, you know, 8 inches per mile.
Yep.
And that flight instructor confirmed that from, you know, here's a guy who's instructing people on how to fly, so he has to know all about the systems and how they all work, and he's saying the same thing.
Yep.
What about navigation?
Navigation is a whole nother beast. I've already came out and said that the way we navigate across the Earth is how it's actually done is a very hush-hush skewed, you know, view on how it actually occurs. And, you know, man, there's so much I could get into on navigation, but basically what a ship uses a gyroscope for, other than, you know, updating weapon systems on where to point and all this stuff, they also use it to maintain what's called true north. And that is what we use to primarily navigate and circumnavigation of the world is what we use as a gyroscope. People throw around the buzzword of GPS all the time, but it might interest most that GPS is not our primary navigation system. And some people will be like, well, that doesn't seem right, because GPS is, you know, it's a global positioning satellite. It's something, you know, it's very accurate. It's something that we can, you know, trust on. And isn't it funny that our military doesn't use that as a primary navigation? We use something that we can actually pitch and yaw around to maintain that.
I went out to San Diego to do a conference a few months ago, and where right next to the airport there was the USS Midway has been turned into a museum, basically, and you can go on the tour. And I walked through the thing. It took me like 4 hours to go through the thing, and for part of it I went on the guided tour where they had a tour guide, and he was a guy who had previously been stationed on the Midway and other carriers and whatnot. And I just so happened to be standing right next to the GPS boxes where I was when they went into the navigation room. And he was talking about GPS and how he said all of GPS is owned, operated, and run by the United States. We just let the rest of the world use it. Is that true?
According to everything I've learned, yes, that's 100% true. It was actually developed by a big think tank organization from, you know, United States government. And a lot of people, the more and more I look into this, if you want to talk about GPS, people should really look up this old system that the military used called the LORAN system, LORAN. And it was a low-frequency, long-range communication system that could repeat telemetry data to different various recipients out in our military, different naval vessels, and it would broadcast and send, telemetry information, which has to do with positioning and all of that. And what this LORAN system worked off of was a radio tower. So it's already, anyone that doesn't know anything about this, I advise everyone, I suggest to everyone, go look up how easy it would be able to recreate, and I don't think it's recreated, I think it's what's actually in use right now, a GPS system based upon a cellular tower model. You get triangulation from different points of where different towers are at, just like you would on the supposed satellite theory. And, yeah.
That's fascinating because back in 2008, 2009, somewhere in that time frame, I started noticing just a marked increase in satellite towers going up in my area where I live. I mean, like they were like all over the place. All of a sudden, just like boom, like somebody just planted cell tower seeds and they just all sprouted at once. And I remember being at a red light and I was talking on my phone and I was losing signal on my phone. But I was literally right underneath the cell tower and I could see two more within visual range of where I was parked at that red light. And I'm going, why am I losing my cell signal when I got three cell towers right in front of me here? And I started, of course, my default setting is conspiracy, so I immediately started thinking, well, what if they're not really for cell phones, And it spun me off in a whole other direction we don't have time to talk about. But so what you're saying or suggesting then is that maybe the LORAN system got an upgrade based on cellular technology, or cell tower technology, and that what we think is coming from GPS, quote-unquote, satellites may in fact just be a beefed-up version of the LORAN system?
Yes, and that's why I believe, without any doubt in my mind, as to why, 99% of all tracked commercial flights by, the established GPS system, you can go look this up on the websites, you can track flights in real time. 99% of all monitored flights are all in the northern hemisphere. Mm-hmm. Now, if you look at the northern hemisphere and equate that to an azimuthal map, a flat Earth map, the northern hemisphere is all in the inner ring of the disk. And that makes sense because if it's established by the United States, most of the towers are constructed, on the northern hemisphere.
Oh, wow, that's fascinating. Yeah, I always wondered, even with the NASA's new program that they have, Project Orion, they retired the space shuttle, and the new project's Project Orion. You watch the videos that they're putting out regarding the development of this spaceship and everything, and there's this guy, and first of all, he talks about the Van Allen belts and how they haven't solved the radiation problem yet, and they have to figure that out before they can send Orion out, and I'm like, well, why don't you just use the same tin can and jumpsuits that you did back in the 60s and 70s? You supposedly went through
that.
There and back 12 times, So what's the deal with that? But one thing that he mentioned, he said, as soon as Orion takes off from, I guess, Florida, it eventually goes over the Indian Ocean, NASA, Houston, everybody, they lose contact with the spaceship. For a period of time, and then all of a sudden everything comes back on when it comes back around or whatever. But that's been the same with the space shuttle. It was the same with the Apollo and Mercury, Gemini, all of them. They lose signal with the space capsule as soon as it goes out over the Indian Ocean. I always found that really odd, especially if if there are satellites up there and they're up in space where the satellites are. 40,000 of them or however many are supposed to be up there, and they somehow magically managed to never run into. Wow. I mean, something's clearly up with that. I know some people say that you, and I've looked at the websites where the airplanes do disappear in the southern hemisphere. Mark's talked about it with the long haul video and whatnot, where you can watch a ship take off from Chile or someplace, an airplane take off, and about an hour out on its flight, it disappears, and then all of a sudden it reappears, much later, about an hour away from its destination on the map. But in the middle, it's not there. Now, others have claimed, and I have yet to see it for myself, but others have claimed that there are different websites out there that do track them going across the southern hemisphere. So I don't know. I don't know what to think about that. But if the azimuthal map is somewhat accurate, and I would contend that nobody knows what the flat Earth currently really looks like. I mean, the AE map is the one that's being pushed around by everybody right now, and I guess it's as good as any. But on that map, the lines of longitude fan out. So your latitude lines are still the same, but your longitude lines, it would seem to me that, like on a ball, everything's pretty much standardized, I guess. In fact, the longitude lines start to converge and get narrower as you get closer to the bottom of the ball. But on the azimuthal map, they fan out. So what's the real world observation of the longitudinal lines when you're navigating at sea in the southern hemisphere?
Yeah, I mean, whenever you're looking at it from navigating at sea in the southern hemisphere, I've been in the southern hemisphere, so to speak, and I've been off the coast of Brazil. I've been off the coast of Suriname, Guyana, and I've been all the way down to the southern end of South America, pretty much close to the tip of it, and we got diverted back to going across, on the Pacific Ocean, and instead of just going around South America when we were by Brazil, just going around the bottom of it and being in the Pacific, we got diverted back towards Panama and had to take a canal route. Now, you have to ask yourself, why does that make sense? That makes no sense economically from a fuel conservation standpoint. It makes no sense from a time perspective of, responding to a call to a certain area of the world. Makes no sense unless the AE map has some validity to it, where the longitudinal lines actually do fan out, because you're talking about the further you go out from the center of the North Pole, so to speak, any travel from east to west is going to be a huge distance.
Yeah.
And that makes perfect sense as to why we were diverted back towards the center of the Earth, so to speak, if you're looking at it from a flat Earth perspective. And that's why I actually believe that the azimuthal is more accurate than not, because the reason why that map even exists in the USGS is because of Admiral Byrd's exploits and explorations back in the 30s and the 40s. When he went down to Antarctica, it was said by him in his own words that he circumnavigated around an ice wall over 27,000 miles. Now you look at his claims of going around something that long, and then you look at the established continent of Antarctica, which only has a circumference of about, I think it was like 9,000 roughly if you go all the way around all of its edges. So that doesn't add up. That's almost 3 times the distance. I believe he was literally going along the outer edge.
Yeah, I think it was James Cook. I'm not sure if I got the first name right, but Cook was a ship captain. I believe it was in 17 or 1800s. I forget, but at any rate, he was one of the first explorers to get down within, I guess, telescope viewing distance of the ice wall, and he was trying to figure out, okay, is there an inlet that we could go into? And according to his log, it took him, I believe, 3 years, and I think he logged 60,000 nautical miles in 3 years trying to get around the thing, and never found an inlet. So And presumably it was, he clocked it from a starting point and came all the way around back to that starting point. So you're like, well, I mean, if the ball is only 25,000 miles in circumference, whatever, why did it take this guy 60,000 miles and 3 years to go around it?
Exactly.
A continent that's supposedly 9,000 miles in circumference. I mean, that doesn't make any sense at all. And I kept reading about other ship captains saying that they were constantly, once this whole baller thing became popular, 500 years ago, there was all kinds of ship logs where everybody's reckoning of where they were drastically off by that type of navigation.
Yeah, I see that in all the research I've done as well. And just one thing to ponder real quick, because I know we're coming up close to the end of the show, and I just wanted to put this out there. You know how there's a different gradient of how they say a magnetic compass works, determined upon where you're at in the world, like how much of a deviation there is from it, like when you go across the longitudinal lines. Yeah, for anyone that knows about that, there's a reason why they say that and they establish that. If you actually look at their established point of how much it deviates depending upon where you're at in the world, when you're referencing true north from a compass, the reason why they have to say that is because there's such a distorting view of how the Earth works and how it reacts to a compass. Whenever you're looking at it from a spherical standpoint, it's actually very equal, and there's no deviation in magnetism when using a compass when you look at it from a flat Earth perspective. Absolutely none.
Now, when you guys are plotting things to navigate on the ocean, you're not plotting anything on a ball. You're plotting it on a flat map, aren't you?
Yeah.
It doesn't make any sense. I have to say, I'm becoming way more convinced now of this model that we're talking about here. That I just see too many other. I mean, all of the counter arguments that I would have. Well, but what about? It's always taking me back to NASA.
Yep, it always leads back to them, and it's funny. You said earlier, well, if you throw out NASA, and you always said that people say that, well, that's our main, sticking point. You can't throw that out. But like you said, consider the source and consider how much stuff that is very easily determined that they falsify. And when they're the ones that hold all the keys to the gate, it's always going to lead back to them.
Yeah. Or any other space agency that belongs to a country that signed the Antarctic Treaty.
Yep, exactly.
They would all have to be in on it at that level. If what we're saying is true, if we are in fact on a circular, still flat Earth, as the Bible clearly says that we are, then everybody that was down there around the time of Operation Deep Freeze and thereafter, when they all left there and signed the Antarctic Treaty, and then NASA was created, from that point on, anybody that was involved with that would have to be, quote, in on it. So that means that all of their space agencies would be just as not trustworthy as NASA, in my opinion.
Yep, and I think so much time has elapsed at this point that it's not so much that people, even at the middle echelons, are really trying to hide it from a malicious standpoint. It's the fact that so much time has passed, the implications of it all have been blurred and grayed out over time. It's very compartmentalized nowadays.
Yeah, and nobody's thinking about it.
Exactly.
It's just like 9/11, and 9/11 is like the gateway to all of this stuff, because when your mind is open to the reality of an evil world out there, and that like 9/11 was an inside job and all that, your mind is open to realize that we are being lied to on a regular basis, and compartmentalization solves so much of the problems because. After 9/11, sort of people started questioning. All of a sudden, you had architects and engineers and pilots and firemen for truth. Here are people who, in their respected fields, that they understand very well. I said, wait a minute, that can't happen. I understand this very well. That can't happen. And I think now that the door is starting to be open, and this is like the most Google analytic hit that I think right now, if you analyze what's going on Google right now, it's got to be Flat Earth. So anybody else out there who are professionals in what they do and who are open now to questioning this stuff, just like the architects and engineers were with 9/11, I know Mark has put the call out. I'm going to put the call out too, man. I want to hear from you. I want to hear what you have to say. And we're running out of time now. We got about a minute left, minute and a half or so. So I'll let you close out whatever you'd like to say. And if anybody can contact you, let them know how to do that.
All right. I'll just say this. If you want to contact me, I'll plug my email right now. It's Sean McCrary, SeanMccRary 42445 @gmail.com. And I appreciate any input I can get from anybody, anyone that wants to work on this. I'm actually trying to establish a group of people that are actively trying to, conduct their own experiments and, perceive and conceptualize new ones. But I always say this, I'll close with this. For those that are doubting this, for those that, are kind of on the fence on the whole topic, just be honest with yourself. Other than that, have a good night.